we have two standard normal curves on our paper. The first one is going to be a distribution of just raw data. So basically nothing has been done to it. If I look at this center value of 7, that is going to be the population mean, which is what we call mu. So in this case, 7 is the center. Remember, if you have a normal distribution, meaning it's unimodal and it's symmetric, it's going to be centered around the true value. Because if I take a bunch of different samples, eventually, as I build out my histogram, it's going to get normal and center around the value. Now, one thing about this is we can see that it jumps to 8.2. So that tells me my standard deviation. And in this case, this particular problem has a standard deviation of 1.2 because I'm adding 1.2 3 times. I'm subtracting 1.2 3 times. And if you remember, if we're in one standard deviation, you should be capturing about 68% of your data. And then if you go out 2, you're getting 95%. And if you're going out 3, you get 99.7. So all of these markers are indicating that we're capturing most of our population within this normal curve. The whole thing in total is 100%. So whenever I look at one of these distributions and I'm starting to pick, am I shading above, am I shading below, it's always going to total to 100%. Now, what we have on the right-hand side is what we're going to call the standard normal curve. And all that means is if I took every single one of these values and I found a z-score for it, so value minus mean over standard deviation for 7 and 8.2 and 9.4, if I come in and do that for every single one, so I'll do 7 as my example, and I subtract the mean, I divide by standard deviation, you should see that as we start to build out this standard normal curve, it just turns into a distribution with a mean of 0 and a standard deviation of 1. So anytime you are working with z-scores at all, so if you have a z-score that has been calculated and you're using it to find a percentage of people, you're always going to use a mean of 0 and a standard deviation of 1. One of the big things that College Board requires on FRQs is that you work in z-scores and not with just raw data. So a lot of what you're going to see us do today is take raw data values, turn them into z-scores, and find a percentage. Thankfully, for the most part, you don't have to think too hard about this. Your calculator has a function that's going to find that number for you. The only thing you have to worry about knowing is the z-score formula and then which calculator function to pick. And we're going to kind of talk about when to use what today, because there's going to be 2 separate ones that we're going to go into. So again, big thing here is noticing that z-scores will always be mean of 0, standard deviation of 1. That is what we want you to take away from seeing how things look when they're standardized. So let's go in and let's kind of talk calculator. So it is important that you get really comfortable with these calculator operations because we use them a lot in this class. So the first one we're going to talk about is normal CDF. And so what you'll do, and we'll kind of use it in just a second, I'm going to put stars around it because it's very, very important. This particular calculator function is used when we are given values or z-scores and we want to get an area or a percentage in return. So this is like our given. This is what we want. So when you read a question and they say, given that Jeff has a score of 90, what's the probability a student in class scored higher than him, or what's the percentage of students that scored higher than him? This would be a normal CDF question because they're giving you Jeff's score and they want you to find a percentage. So anytime they give you a data value, sometimes they'll even give you a z-score already, you're going with normal CDF. Now, it does ask you a couple of different questions. So there are a variety of options for what we can select. So option-wise, when it comes to normal CDF, just to kind of sketch a couple pictures so you can kind of see what I'm talking about, I'm going to draw a few of them just so I have. Let me draw before I switch. 3, we'll do 4. If you cannot draw a normal curve well, don't feel bad. I've been doing this for 9 years and mine still look bad. So it's not the end of the world. So when it comes to a normal CDF question, you're trying to figure out what the shaded region is. So area-wise, what is the space that's taking up? Now, a lot of these you're familiar with from what we did with empirical rule. So there was questions where they said, what's the probability it's less than this or greater than this or in between these two values? And you just added up those sections. It is the same idea. It's just you don't get perfectly standard deviation lines. Now, these are kind of the 4 options you can do when it comes to a normal CDF question. The one thing I want to point out is it will go all the way to negative infinity if you are shading below. It'll go all the way to positive infinity if you're shading above. And the same thing kind of applies when you're going outside of. So when we create these bounds, we will use in our calculator the calculator version of infinity. So in the lower and upper, that's where you're going to put your restrictions. So sometimes it's going to be a z-score, or in the case of lower, it could be negative infinity. The upper could also be a z-score, or it could be positive infinity. This will all be dependent on your question. So if they want above, then you're going to have a positive infinity as your upper bound, z-score as your lower bound. And you'll kind of see what that is once we attach it to some questions. In the case of z-scores, you're always going to use 0 and 1, and I'm just going to make a note, always for z-scores. There is some instances where we will change these values and we won't always use 0 and 1, but we'll kind of talk about that once we get to it. So normal CDF is you want area. So you're trying to figure out what is these areas that we have in our graphs, and you have values. So if you ever get a question and they're asking for percentages, you're using normal CDF. The biggest difficulty I find, having taught this for as many years as I have, is a lot of people don't know what calculator function to use for certain questions because they're not going to specify use normal CDF to find the percentage. They're just going to say find the percentage. So knowing that this is used for that helps. So let's go in, let's try some out. What percent of data is below a z-score of 0.54? So I'm going to kind of show you what an FRQ response should look like. The first thing that you have to have is a calculated z-score. And in our case, they gave us a z-score. They tell us it's 0.54. So I don't have to use the value minus mean over standard deviation. I can kind of just use what I already am given. Now, the next thing that College Board requires is that you have something indicating direction. So you can sketch a picture like what I have up here. Another option is you can go in and say, I want to find the probability that z is going to be less than 0.54. Now, I'm going to include both options so you can see both. Some people prefer probability statements, and some people prefer just drawing a picture. If it's z-scores, it's always going to be centered at 0. You don't have to label the whole thing. So I know when we were labeling 3 standard deviations, we added 3 all the way out. If you're just finding a singular value, all you have to do is just make sure your number's on the right-hand side, like if it's positive, it's on the right, if it's negative, it's on the left, and you just have to shade your area of interest. So if I'm doing everything below 0.54, that means I'm shading everything underneath 0.54. And so either one of these is enough. So you don't have to do both. Some people prefer the picture, some people prefer the words, but you have to have something indicating direction. So I'm just going to make a note here. One or the other. If you want to do both, you absolutely can, but you only need something indicating direction. Once we know what direction we're in order to get credit for the calculator work that you do, you have to name the calculator function you're going to use. So we're going to use normal CDF. That's the only thing we know, so that's what we're going with. And I'm going to show you in just a second, but normal CDF asks you 4 questions. They're listed in the little box above. It's going to ask you, what is your lower, what is your upper, what is your mean, and what is your standard deviation? Again, anytime you're dealing with z-scores, your mean is always 0, your standard deviation is always 1. For the most part, 9 times out of 10, you are not changing those values. They're going to stay 0 and 1. Now, in order to do a lower and upper, so on your paper, you're going to write, I'm going from negative infinity all the way up to 0.54, because you're telling your calculator what you want it to look at. You want it to go from the very, very bottom all the way to 0.54. Now, a little disclaimer before you get there, because some of you might be seeing it now. This infinity symbol, there is no infinity key in your calculator, so we kind of simulate it using a really, really big number. So what your calculator does is it uses -1e99. Now, if you wanted to type this in yourself, it would be the -1 button. The E is going to come from second, comma. And the comma is above the 7. This is comma. I know it looks like a 1, but it's a comma. Now, all that is scientific notation. So it's saying I'm taking 1 times 10 to the power of 99. So what we're going to do is we're going to plug this into our calculator. We're going to make sure we all know how to put this into our calculator because it's the easiest way to kind of go about this. So let's go through the steps together. They are on your paper. So in the part that I highlighted that said second VARS normal CDF, I'm going to kind of show you what that looks like on the TI. So second is the blue button. The VARS button is 3 above the 9. So if you go to the 9 button and you go up 1, 2, 3, you should see the VARS. It's right next to clear. And then we are going to use normal CDF. So CDF stands for cumulative. So that means it's adding up all the area until we get to 0.54. So we're going to do CDF. And now yours should have prompts. Mine doesn't just because it's an iPad emulator. But it should ask you 4 things. So the first thing you should have is -1e99. Most likely your calculator already has that there because that's kind of how the base operation starts. So I'm going to do -1. I'm going to have E and 99. So E again is second comma. Comma is above the 7 if you have to type it in yourself. And then it's going to go all the way up to 0.54, mean of 0, standard deviation of 1. And then we're going to hit enter. And you should be getting 0.7054. So again, lower is -1e99, upper is 0.54, mean of 0, standard deviation of 1. So what I do when I get this value is the percentage of people. It's a proportion, but it's a percentage when we convert it. If I want to turn this into a percentage, I can just come in and multiply it by 100. You can also just move the decimal place 2 to the right, but we always want to make sure we're rounding to at least 2 decimal places. So if I'm taking it from a proportion, I usually will write 4 decimal places, and that's so that when I convert it to a percentage, I get 2 decimal places in the end. Now, you don't have to write the proportion value if you do not want to. If it's asking for a percentage, you could have immediately just written down 70.54. But sometimes on my keys, you'll see that I round some of these decimal values to 4 decimal places. This is why, is if it ever had to get converted to a percentage, it's still going to show the minimum of 2 decimal places. Okay, do I have any questions? Did anybody not get the right value in their calculator? Wonderful. Okay, so we're going to kind of do some different scenarios, run through a couple of different things, and talk about how this normal CDF function works. So let's go in. We have what percent of data lies between negative 1.64 and 2.33. So again, I already have my z-scores given to me, so I don't have to calculate them myself. I'm going to go ahead and do my probability statement. I'm going to keep doing both just so you can kind of see how they would be written if this is the method you prefer. But if I were doing it as a person answering the questions, I'm a picture person. I'm drawing a normal curve. I'm shading in between. I do think that's a little bit easier, but that's me. So I'm going to have negative 1.64. I'm going to have 2.33. And the areas that you draw don't have to be like to scale. They don't have to be perfect. They just want the right numbers on the right side. And they want the shaded area to be accurately represented. So I'm going in between these two values. So now that I have this part, I'm going to go straight to normal CDF. And it's going to ask me the same 4 questions: lower, upper, mean, and that's always 0. Standard deviation, that's always 1. Bless you. So in this case, because we're not shading above or below, it's going to go from negative 1.64 to positive 2.33. So we don't have to necessarily use the infinity symbols for this problem because I have 2 z-scores. So a lower bound and an upper bound that is a z-score value. So I'm going to run the same exact steps. I'm going to go to second vars. I'm going to go to number 2, which is normal CDF. Negative 1.64 is my lower. 2.33 is my upper. And I'm going to hit paste. And I am currently getting 0.9396 if it was still a decimal value. Now, this question is asking for what percent. So I am going to go ahead and change that to 93.96%. One thing that I noticed yesterday with the math lab assignment is sometimes they give you a blank and there's a percentage sign attached. So a lot of people had the right answer. It's just they hadn't converted their number to a percent yet. So be careful when you're answering those questions because it has to be a percentage. So in this case, 93.96% fall within negative 1.64 and 2.33. Now for the AP exam, a lot of the time they will lead you into other questions. So when I look at question C and I see that I have what percent of data lies outside, if I do my same picture, negative 1.64 and 2.33, the area that I'm interested in for this one is underneath and above. Now, you have 2 options for this type of problem. One is you could come in and you could take the probability that z is less than negative 1.64 and add it to the probability that z is greater than 2.33. And you can find those individually, combine them together. If I didn't have part B, that might have been an option for what I wanted to do. With us having done what we did in part B, I know that the in-between, so I know that this area between these 2 values totals up to 0.9396. Like I found that value already. So what I can do instead, option number 2, is I can say that I know this whole normal distribution is 100%. I know it's a 1 total. So what I can do is I can do 1 minus that probability that I just found of negative 1.64 less than z less than 2.33. And I can use that to find the outside area. So all I'm doing is 1 minus 0.9396. And so if you have a question like this and you've already shown your work, which I did in part B for how I found 0.9396, you don't have to write it again. So I'm not going to write normal CDF for this problem because I've already done that. And every time a person grades your FRQ, we are not just grading parts. Like they don't just assign us to, oh, Mrs. Martinez is grading part A, somebody else is grading part B. We grade your whole question. So if I see that you have that work, it satisfies part C. So in this case, 1 minus 0.9396 is going to give me 0.0604, which is 6.04%. I would still get the same answer if I had used method 1. However, if I'm going that route, most likely I would have to show how I found those individual sections. So I'd have to write out 2 normal CDFs. You can still use option 2, even if you hadn't calculated it already. I probably would pick option 2 over option 1. Okay, so we, in these last couple questions, have been given a z-score. The only change for what we're going to do next is they are not starting us off with a z-score. They're starting us off with data. So we have to find the z-score for these particular questions. So for example 2, they're saying a Kroger reports the mean amount of money spent is 2721, so that's my mu, and standard deviation is 7.93, that's my sigma, and the distribution is approximately normal. So I'm going to go in first, and they're asking what percentage of people spend less than $20. If this is an FRQ, you have to find a z-score first. So step 1 will be finding that z-score. So I'm going to go in, and I'm going to do my value, which is $20, minus my mean, which is 2721, all over my standard deviation, which is 7.93. And so that's going to give me a z-score for this particular value that I'm interested in. So 20, 2721, divided by 793. And if I round this to 2 decimal places, I'm going to get negative 0.91. So what I'll do with that z-score is I will go in and I will draw my picture or write my probability statement. Up to you. Z is less than negative 0.91, or you can sketch a quick picture. If you're dealing with z-scores, it's centered at 0, and then you are going to have negative 0.91, and we're shading everything below. So again, you don't have to do both of these things. It's one or the other. And I'm going to kind of write out in a second like what would be absolutely required. Now that I know what I'm interested in, this is a question where they gave me a value, they want a percentage. So I'm going to say normal CDF, and I'm going to do a lower of negative infinity. Now, the one thing that College Board says, like they let you use your calculator, they let you do all of these things, they do not like for you to write negative 1e99. So we have to write negative infinity. It's the hill that they've chosen to die on. They've said calculators are fine, but negative 1e99 is too much. So we don't write it. Upper is going to be negative 0.91. Now, just again to remind you, if you have forgotten that note, this will actually just go in as negative 1e99. So I go to my calculator, I go to second vars, I go to normal CDF. You will most likely have to type in negative 1e99 yourself because it probably has the information from the last question. So negative 1, E is always second comma, and the comma is directly above the 7. And then it should create like a little tiny capital E, and then you should have 99. Technically, you could go bigger. Technically, you don't even really need the 1, but all it's doing is making a very, very, in this case, small number. So I am getting 0.1814. Yes, making sure my rounding is right. So if they wanted to know what percentage, that would be 18.14%. Okay, so this is kind of where I start kind of skipping around and saying that we've done many examples. I am going to look at part B because I want to show you the instance where this, if this were a multiple choice question. This is very much an FRQ, but I'm going to make a little note that this is for multiple choice only. On multiple choice questions, they do not require that you show any work. No one is going to look at your, it's not even a test booklet anymore, it's a computer. No one is going to see your scratch paper or what you have. So what you do in the multiple choice section is up to you. Now, first thing, if it's an FRQ question, just to kind of point out some things that you need, you have to show your Z-score, bless you. You have to show direction. So again, that's something you can choose. You have to show your calc input. And that includes labeling, lower, upper, mean, standard deviation. You cannot just list the numbers. You have to label them. You have to say normal CDF, those 3 things, and then you have to have your answer. So if you wanted full credit and it was one of these types of questions, you have to have all 4 things if it's an FRQ. Multiple choice is where the game kind of changes because you're always using 0 and 1 when it comes to an FRQ because you're always finding a Z-score. If I had this question part B on the multiple choice section, I'm not approaching it in the same way. The first thing I'm going to do is I'm going to kind of see, okay, they want to find above 40. So in this part, you don't even have to draw a picture. I'm going to draw a picture just so you kind of know what we're talking about. If I were to just look at this as data values only, that means that this distribution wouldn't be centered around 0. It would be centered around 27.21. And this, again, kind of like what we had on the first page, is a raw data distribution. They want to see what percent of customers spend above $40. So that means I'm coming in and I'm shading everything above $40. Now, again, if this is multiple choice and you know above means we're going to positive infinity, you don't even have to sketch a picture. But just to show you what we're doing, I'm going above 40. Now, once I know what direction I'm going in, if this were multiple choice, I would go to normal CDF. And instead of using a Z-score, you can go ahead and use a lower and upper bound of the data values. So I can say we're going from 40 to positive infinity, and the mean is going to be 27.21, and the standard deviation is going to be 7.93. So the only time you will be able to adjust the mean and the standard deviation to match the question is if it's a multiple choice. Otherwise, you will have to calculate a Z-score. You done? Okay, you can drop it on my desk. you do in multiple choice is completely up to you. So if you still want to find a z-score and you still want to use that to use normal CDF, you can. You're going to get the same answer. So what I'm going to do is I'm going to go to my calculator and I'm just going to plug it in as is. I'm not going to find the z-score. I'm not going to standardize. I'm going to leave it alone. So I'm going to go to my calculator. I'm going to go to second VARS. I'm going to go to normal CDF. And this time my lower is 40. My upper is 1E99. So second, comma, 99. And then the mean is 27.21. And the standard deviation is 7.93. And so we should get a probability of 5.34. And if I had gone in and found this using z-scores, I would get a probability of 5.34. Now, sometimes when we do the z-score calculation, it is a little off because we've rounded in certain steps, but it's never drastically different. It's usually within like 0.01 of the actual exact answer. This method produces an exact answer. So in our case, we're going to say 5.34%. So in total, 5.34% of people spend above $40. Now, please, 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 every year I say, when you take this test, there will be FRQs. You have to do it using method A, not method B. Yes, they will give you some partial credit for having the correct percentage in the end, but you are going to lose out points on having your z-score calculation. Most likely, you probably didn't even draw a picture. You just went straight to normal CDF and you got an answer. So you're losing credit when you don't do those parts in an FRQ. Yes, Tasvia? I'll double check it in just a second.
Why did they make you do this?
Because the calculator, so before, the calculator wasn't an option on the AP exam. So the z-score, when you get your test, there's in the formula chart, there's going to be like 7 different tables of like you match your z-score to your shading, and then they have like a bunch of numbers listed. So there's a very old school method of finding this area using a list of tables. So part of that work, because you didn't have any calculator options, was seeing the z-score, so knowing what they went back to and saw in that table. So it's just something that's been left over from that. So it's on every single grading rubric. Okay, now for the sake of time and for the sake of we've done a lot of this repetitively, I'm going to go ahead and skip C because it's between 2 values. And I'm going to jump over to the other types of problems. So this is kind of the reverse of what we just did. So we had z-scores and data, and we went to percentages. Now we have percentages. We're going to go to z-scores and data. So the first thing is the calculator function is going to change. Second VARS, inverse norm. And so what this function is going to do is it's going to take area and percentages, and it's going to change it to values and z-scores. Kind of looks like z-scares, but we want it to be z-scores. Okay, so what you're doing instead is you're kind of doing the reverse of what we just did. You are starting with the percentage or the area, and you're taking it back to a value. So we're going to talk FRQs first, and then we'll kind of talk how you can approach this with multiple choice type questions. Here's where a lot of things start to split. Depending on the calculator you have, and it may even be one of my calculators because I know some do it and some don't. I may be able to update it. I just haven't found the ones that don't. Sometimes these calculators will have an option for tail, and the tail will say left, center, right. And all that is doing is asking where the shaded region is. Is it on the left? Is it in the center? Is it on the right? If your calculator does that, you can just type in the area as is. There are calculators that don't. So I teach this as if your calculator doesn't do that, and your option is always on the left. If you want to play with the tail and change it and you understand how it works, awesome. If you don't, you just follow what I'm doing and you never touch the tail option. You leave it at left and don't worry about it. We're still going to use mean of 0, standard deviation of 1, because we will, for FRQs, be having to find a z-score. So the first question says, on a typical school night, students get an average of 7 hours of sleep with a standard deviation of 1.2 hours. How many hours of sleep would a student need to get to be in the 75th percentile? So one thing to remember about percentiles is whenever I have a normal distribution, it centers around the mean, which is typically going to be the 50% mark. It is the 50% mark. And then we have everything underneath represents a percentile. So if 50 is in the middle, I know 75 is going to go past that. So we need to figure out what z-score cuts off this area. And so we know that this area is 0.75, and it's on the left-hand side, so I don't even have to mess with the tail option. So in this case, we're going to have a positive z-score because it's above 50. If they had asked for the 25th percentile instead, I should have had a negative z-score and it wouldn't quite hit that middle marker. So now in order to figure out what this z-score is, now I am going to get my people who are like, well, if I want to write the probability statement, what am I supposed to write? So these get a little weird, but you kind of have to say probability z is less than some number. Like we don't know what it is. And we know that that's going to be equal to 0.75. Usually when it comes to finding values, most people prefer the picture just because it's a little bit easier than writing out a probability statement. Okay, so I'm going to go in. I'm going to do inverse norm, and luckily enough, all of the things we really use end up being in the same menu. So you're still going to second vars. It's just this time you're going to option 3, and the area you're going to enter in is 0.75. If you only type in 75 as a whole number, it is going to give you an error. It has to be a proportion of 1. So 0.75, 0.50, 0.02. It has to be a decimal. Mean of 0, standard deviation of 1. So I'm going to go to my calculator. I'm going to go to second vars, number 3, 0.7501. And this value that it's giving back to me is a z-score. So this z-score is 0.67. So I'm going to write down z is equal to 0.67. So step 1 is get the z-score. Again, we're talking if this were an FRQ question and I'm trying to show all my work so I get full credit. Once we know what the z-score is, College Board has you go in and it has you write out the formula for how you find a z-score. So remember, z is equal to value minus mean over standard deviation. And I know 3 of these 4 things. Huh? From 2 doors down? Okay, I'll come in just a second. So for this function, we have to go in and we have to take 0.67 and we have to, I'm going to use x. You could write value if you want. I usually use x when you look at my keys and you're going to see my work. Minus the mean, which in this case was 7 hours, over the standard deviation, which is 1.2. And then we solve for x. So let's try solving for x while I go make sure this is not a disaster. I'll be right back.
this one. He said he didn't know how to use it.
They should have shown you a video on how to use it. I cannot help you with it. I can help them normally.
Oh, yeah. Okay.
You're welcome.
Awesome. I just got my picture taken, so I'm amazing. Twice as handsome as my father.
No one's dead, so it's okay. No one's hurt. Just don't know how to use a calculator, which is always fun. Okay, which I can't help you with on a test. So just very much some steppies in the middle of a lesson. Okay, so if I want to solve for x, what is the first thing that I do? Times 1.2. Times 1.2 times 1.2. That should give me 0.804. And here's my Algebra 2 brain as a teacher. Could I have added 7 first? No, you cannot add 7 first. You cannot. Order of operations. So in total, we get a value of 7.804 hours. You do have to include units. We are talking about hours of sleep. You could even go as far as saying hours of sleep, and it would work just the same. For the next question, I'm trying to decide which ones did I do in the other classes. I think I skipped 4 and 5, so I'm going to skip 4 and 5. And we're going to jump all the way down to part B. So I only skip these because it's just different variations of the thing we are currently doing. And if you get it, it kind of gets to be long if we're doing the same thing over and over again. So for part B, we have an automobile dealer finds that the average price of a previously owned vehicle is $8,256. He decides to sell cars that will appeal to the middle 60% of the market in terms of price. Find the maximum and minimum prices. So they want us to find the max and minimum price. So that means they want us to find a value. So when I see this question, they gave me a percentage. They gave me middle 60%, and they want me to find a value. So that tells me immediately that I'm doing inverse norm. So again, normal CDF is they give you values, they want percentages. Inverse norm is they give you percentages, they want values. The standard deviation is 1,150. So I'm going to go in, and just to kind of talk about this by hand first, if I were drawing this out and I'm trying to find z-scores, middle 60%, and because they specified that it is in the middle, that means because of the fact that these distributions have symmetry, and I have negative z and I have positive z, these two numbers should be the same. One will be negative, one will be positive, but the actual value will be the same. And this area in the middle is 0.60. So just to kind of talk about approaches, if your calculator does not have the tail option, you have to remember your calculator is always reading from the left. So if I read from the left to one of my z-scores, so if I'm reading from here up until the negative z-score, if there's 60 in the middle, how much should be in each tail? 20. So that means there's an area of 0.20 on the left-hand side of negative z. So again, this is for my people who don't have the tail option or don't want to bother with it and mess with it at all. I would go in and I would do inverse norm. I would put in a lower of negative infinity, which is negative 1e99. Or no, sorry, wrong thing. Area. Completely switch gears. Area would be 0.20. Mean of 0, standard deviation of 1. So if you don't have the tail option, and even if you do, and you leave tail at left, this is what you're entering in. If you do, just to kind of show you what that would look like, we would say inverse norm. We would say area is 0.60, mean of 0, standard deviation of 1, and your tail option would be center. So the difference between these two things, for the one on the left, the blue one, that is going to give me a z-score of negative 0.84. And then I will know that because of symmetry, the other z-score should be positive 0.84. And this only works if they tell you it's in the middle or it's symmetric in the middle. If they just say like, here's a lower of 20 and an upper of 70, and you don't know that it's still cutting off the middle, you can't do anything. You have to kind of find them separately. Now, in this case, for inverse norm, it's going to do the same thing, but it will give you both values at one time. But they'll still be the same, negative 0.84 and positive 0.84. Now, once you know what they are, you're going to set up your equations. You will have to find them both separately because you have a positive and a negative. I'm going to go in and I'm going to subtract the mean and add divide by the standard deviation for both of them. Negative 0.84 x minus 8256 over 1150. College Board does not require seeing your algebraic work, so you don't have to say that you're multiplying by 1150 and you're adding 8,256. I even just do all of that in my calculator and don't actually write anything down. I am going to say that the minimum price is $7,290. The unit in this case is dollars, which is why I have my dollar sign. And I'm going to have 0.84 times 1150 plus 8256. And this is going to be my max. So 9,222. Now, just to kind of talk about this as a multiple choice question as well. If you wanted to do this as multiple choice, and I'm going to make a MC only, you could take the mu and make it the 8256, and you can take the standard deviation and make it 1150, and it should still return 7,290 and 9,222. So even on your multiple choice for this class, because there will be some multiple choice questions on your test, you don't have to show any work. If you don't want to find a z-score first and get the area or the value, you don't have to. But if it's an FRQ, I have to see some type of direction, a z-score, your calculator input, and your answer. So just make sure that you're remembering that FRQs require that. Multiple choice, you can alter these values as much as you want. Just make sure that you know for FRQs you have to show your work. Now, here's my kind of disclaimer for some updates. Over the summer, and by summer I mean like July, so when no one is thinking about AP Stats, including me, they announced that they were going to allow Desmos on the AP exam. So it was on calculus last year. Stats, it was not capable yet, and they released that information in July. I don't feel like 100% confident in teaching you only in Desmos, so that's why we're still using the calculator. Personally, the calculator is going to work 100% of the time. Desmos is a little more intuitive, and so I do want you to see it if you want it to be something that you use, because it's going to be on your test. The only issue that arises with using Desmos is we don't know how they're going to grade it. They did not release any FRQs with grading rubrics attached so that we know what has to be on your paper. I can look at those questions and tell you exactly what you need from your TI calculator to get credit, because we have millions of rubrics to look at and see they require this, 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 and this. Desmos is me kind of making my best guess as to what you will have to have on your paper. So I'm going to show you it, and we're going to kind of talk about it. My best guess for what you're going to need, I wrote it down, and so I think, and you'll see what I'm talking about in just a second, I think you'll have to have this type of notation in order to get credit. The only difference will be you won't have normal CDF or inverse norm. So you'll still have to have direction by the probability statement. I think they would still be willing to take a picture, and then you'll have to describe how you're doing your normal distribution. Again, this is me fully guessing. My hope is they release some type of grading for it prior to us actually taking the exam. So here's what it means for you. I will let you use Desmos on your tests in here. However, it has to be on a school-issued Chromebook. So if you know your Chromebook is dead and it's never going to work again and you're just turning it in at the end of senior year, probably not your best bet, because I have to be able to have you on GoGuardian where I can lock you out of everything else but Desmos. So if you want to try it, you can, but if you're like, I'd rather not work on my Chromebook, I'm just going to stick to the calculator, I know how to use it, stick to the calculator. So we're going to briefly kind of look at it together. So if you take out your computer, the link is actually typed on your notes page. So it has to be the College Board version. That is the version that if you're taking the test with Desmos, I am going to unlock for you. So let's see if it works. How do I get out of here? Let's delete this. Let's close this. Is there a way I can escape from this? Oh, there we go. I'm gonna hit done, and then I'm gonna start again. Okay, so with Desmos, it has to be the College Board version just so that you don't get any features that are not supposed to be there when you actually take the test. For creating an inference model, you're going to hit the little plus sign and you're going to go to the last option, which should say inference, and it's going to pull up a bunch of different options. For now, the only thing we are working with is probability distribution, and it's going to automatically populate a normal distribution, which is what we want. So if I'm working with z-scores, I'm going to make the center be 0, standard deviation be 1. That's exactly what we did anytime we were using our regular calculator. And then we hit create distribution, and it should create a normal curve on your computer. Now, once you go to the cumulative property or probability, you have some options. So it'll tell you, like, if I'm trying to find area, I can do the inner area, the outer area, the left area, the right area. So you can kind of look at the picture you sketched and pick which one matches it. Now, you do get to give it some bounds. Like, I can come in and say, I want the X to be greater than 1.5 standard deviations. And it's going to tell me that that area is 0.067. So this function works just like normal CDF. So I would imagine if you had this as your work, instead of normal CDF, you're probably going to have to write normal distribution. I would still write standard deviation. So I put on your paper that you'll probably need 0,1. So I would put 0,1. And then you're going to have to include whatever the probability statement is that you're doing or a picture. Now, to kind of flip this, you can also look for bounds. So this would be the inverse norm function. So kind of thinking about the problem we just did, I could go in and do inner, and I want the inner area to be 0.60. So I'm going to change this number to 0.60, and it's going to give me the two z-scores that I found using inverse norm. This is an option if you want to use it. Now, I'm not going to restrict you from it and say, like, we're only doing the calculator because that's all I know. I'm learning this as you learn this, but in the same way on a test where I could not help you with your calculator work, I cannot help you with Desmos. So yes, you can use it, but it has to be something, a device, where I can see you on GoGuardian and you will be locked into a scene that is just the Desmos calculator. So if you don't even know where your Chromebook is currently, probably not your best bet to depend on using Desmos for the test. I will still, throughout this whole year, teach you using the calculator, but I will also do my best to figure out what the counterpart is in Desmos so that you have an option for both of them. Okay, do I have any questions? Wonderful. I'm going to go ahead and open up your practice.